We'll start now. I have this server machine with me. This is Windows Server 2019 hosted on the cloud. I'll be using this machine to start containers. We'll see how it works actually. So basically this is how it started. It starts. You just have to install the basic PowerShell module which gives you all the commands for the Docker. Microsoft adopted this technology, Docker engine, into Windows Server. So you just, there are in the repository, everything is available. You just have to download and install them. Download is also automatic. When you invoke this command, you will get all the Docker commands available. And definitely, this is another command that you need to install the Docker engine itself, the main functionality of Docker. So you will use this command, and a single restart, your server is up and running with the Docker engine. That's how simple it is. And you can also run this technology on Windows 10. Windows 10, there is a recent flavor of Docker available which is called Docker for Desktop Edition. And you should not be using this technology. Not. I'm saying not because in desktop edition, there are more chances you will run into having only the Hyper-V isolation mode. Most likely. So it is only the server edition where you get the proper process isolation. It is possible to achieve it in Windows 10 also, but as I said, the matching image you might not be able to find easily. So there are more chances when you're running on the desktop edition, you will not be able to experience the true Docker process isolation, which I am going to show you in Windows Server mode, and you are going to see for yourself also how to run it. So here in the server, I have already run all those commands. So basic Docker command set should be with me now. So this is how the basic Docker engine commands are. And this is the command to see what are the images, base image basically. Base images are different from the other images. I'll be talking about them. Okay. So these are all the base images I have. If you see, I have Windows Server Core base image, 4.94 GB. It's a very small size. But if you see the other versions, they are even smaller. Some even to 343 MB. I do not have the Nano Server here because one initial consideration, as I mentioned, the base image should be corresponding to the version of the server that you're using. I'm using 2019 version. You might be using 1809 or 1803. As I said, the base image have to correspond to that. So for me, I have to use server core, but you could be using whichever correspond to your particular server. So here I have these images, and I'll be showing you one application which will be running, which will be containerizing, which will be running in a Docker container. I have, I won't start with a complicated application. I have one application which I created using Visual Studio 2019. It's a Scratch project. It's a basic template of ASP.NET. I choose the Blazor template. You may choose whatever you feel like. But additionally, in Windows 2019 machine, which is not here right now, but you could use any Windows 2019 machine and create a basic ASP.NET project, Scratch project, a blank project, and you just select additional option of Docker support. It will generate additional file for you to reduce your complexity of using the Docker container. This is the project, for example, I got. Besides the ASP.NET project, it gave me a additional file, a single file, which is called a Docker file. The reason I took the file from there, I could have created a .NET template from here also, but this one eliminates all the the groundwork that you have to do otherwise. You really don't need to learn all the syntax of the Docker and everything. These things are readily available. So you can use them. Of course, it's good to know all the syntax and parameters to fine tune them. You will be learning them. But the basic concept, I'll tell you. It starts off with the base image. And I already showed you that there is a Docker Hub available, which is a core repository of all the base images which is present there already for you. So there available across the board to everybody actually. You do not even need to create a Docker account for that. So you just make customization on top of those base images, and you make your customization in the form of layers. This layer approach allows extreme amount of flexibility. I mean, I mean, make a copy of this customization file along with the actual code that you are copying here in this tab, for example. And then in universally anywhere you can take your customization along with the things that you're copying to those containers, and you're up and running with your setup. That's the core, the advantage behind that. It gives you enormous amount of portability. I mean, comparing to what we had earlier, you have to copy GBs of virtual hard disk file, a virtual machine that you're carrying for your setup to the production environment or to your demo environment. But here now things are much streamlined. You just have to copy on this Docker file for the Docker engine, as well as your main application executables or the source code or the packages, and then you are up and running with that. So the portability is very, very good. Besides the other benefit that we talked about. So we'll be looking more into this file because this is the core concept of how Docker engine operates. It reads this file and does whatever listed in that file. So basically we are using, for example, the ASP.NET base image. As I said earlier, you have to match the image to your operating system. As per the source code, the Nano Server was listed here, which is an even compact size. But for my OS, I had this version available. So we'll see core ASP.NET. So if you notice, here it is, ASP, I have this already available. With the ASP.NET core version 3.1 already with me. So here what I am doing, I am setting a directory and exposing the port 80 on this application because this is a web application. So here we have, if you notice, I am essentially copying all my source code. .NET Core, if you are familiar, this is how you build up your project actually. And this is how you put all your packages and everything into one publish folder with the .NET publish command. So within this Docker container environment, I'm publishing all of my working code into one folder so that IES can simply execute it. So this is the entry point instruction as per the base image where the execution will begin in the container. You'll be starting to understand this thing in a shortcut when I run that. So here the main key takeaway is that this is a Docker file that gives the instruction to the Docker engine what to do with the containers and what to do with the overall project. So I have just copied this project from the same basic scratch template and I opened up in a Visual Studio Code here. So I'll just show you how it works actually. I have something else running on this. This is a basic command how to run the Docker engine on top of the Docker file so that it can read the instructions from the Docker file and move along. So Docker build, and this is the location of the Docker file, which is here for example, and then this is how I am tagging the image that I am developing, and then I'm giving extra labels to it. And then this last thing is the main project folder, which is needed for that .NET command to build this project. So I'll be just executing this command now. So here it very quickly executed all the instructions that I gave one by one, eventually creating for me another image. Basically Docker revolves around images. Images are what the captured form of the operating system is. From it, basically it initiates or instantiates an operating system instance for you. So here we have, for example, now if I go to the list, Docker images. So if you notice now, here we have Blazor app to dev. This is what was created earlier. Now we have this image now also available as an additional layer on top of server code. So either I need to just copy this file and the source code, or I need just this thing, Blazor app to dev this layered image to be able to run my production container anywhere universally in any Docker environment. So this is the benefit. And you can also use your private registry of the images. I mean, instead of using the global repository of Docker Hub, you could also use your private repositories also. So this is where I just created the image. The container is not yet created. By the way, in order to list the running container, this is the command docker ps. Right now there is no container running. So we will run this container to see how this works. And this is how I just ran this container. I mean, the command was simple. It's just docker run, and I'll show you again. There is a command docker run. IT is interactive, and rm is to delete this container once the execution or the process stops. I told you that this is a process virtualization, so the core focus is on the project, on the process, sorry. And this P is the port binding. I mean, I could use, in order for me to use this web application, I have to connect to port 80 of the container. So I could either use the IP of the container, which is also a possibility. But there is one more convenient switch that they have given. I have redirected the port 80 of the container to port 5000 of this host itself. And similar, I'm doing to port 443, I have forwarded it to port 5001. And I'm naming this container to my Docker. I could remove this switch and it will give a random name. And I'm at the end selecting which image to create this Docker container from. Definitely I worked and put in all my code into one of the Docker containers, which is already containing ASP.NET and the .NET Core 3.1, which is a prerequisite for this course. So this is how I initiated this container. So I initiate it again basically now. Good. And now your application is running, right? And it's listening. We will be connecting to it shortly. Before we do that, I will like to run the command again, and you will see our container is in action now. Now I will be connecting to this container, and let's see how my application works basically. So this host, if you notice, this IP is 13.94.57.57. It's running in the cloud. I have this public IP with me. So I'll use my desktop, and from here I'll connect to this application. So this is the IP and this is the port 57. I use the Blazor template. So I have the Blazor application in front of me now. This is a server-side Blazor application by the way, if you're familiar with the ASP.NET new Blazor technology. But you may consider it as any ASP.NET web application to keep it simple. So it's up and running. But the most important thing I want to tell you is, because we want to know what's happening inside the container, what is the environment given. So I have modified this application basically a little bit so that we can peek inside the container. Like for example, there is a page fetch data which I haven't clicked as yet. I just put in some custom code in there for in order to probe inside this container. I've written some code to fetch in the machine name, to get the current process name, the process ID, how much RAM is there in the container, what are the disk attributes, and what are the total number of processes that are there. This code is so that we can see what's going on inside the container. We can see and learn things more from the container. So now if I click on this page, here we go. We get the host name of the container. We come to know that this is the total amount of RAM, which is 16 GB. We come to know that 20 GB disk is provided to this container. And we come to know that these are the total number of processes that are running in the container. So we'll start out by host name first. As you see, this is some arbitrary host name, while our host, actual host, which is hosting that container, its name is different. With server 1. We'll move on to see, for example, the web application is working on process number 2012. Since this is process virtualization, you will be a bit surprised to know that that this process 2012, if I go to this host, if I show you from here, for example, in the details, and if you go here, for example, 2012. Now here is the catch actually. This is the host which is not running this IES, right? It was supposed to be running the container which should be running this IES application. But remember, we talked Docker is essentially a process virtualization only. So this is exactly that process which is it is running, and that is the beauty of the Docker itself. I mean, you could create n number of this Docker container in this host, and each will run without even knowing that there is another Docker container running on this host. Total isolation, but each itself will only be a single process. So if you notice 2012, here is also the same process 2012. So the same OS, host OS, is treating this whole container as a single process basically, but the host name actually is different, but inside it's virtualized by the Docker engine. You get entirely different host name. You get same amount of RAM which is in the host, 16 GB here, and if you notice here, it's also 16 GB, and the disk is entirely different. I got, for example, two disks here. None of them is 20 GB, but to the container, the disk is presented as a total 20 GB. You see here, megabytes. One C drive, 20 GB. And I have bulk load of processor running on the host. If you notice here, there's so many processors. They're running. Only few of them that belongs to that container, they are also listed. But within the container, I see only the process that belong to the container and nothing else. So this is a subsidized and stripped down environment which is called Docker container. Now, this is marvelous because this gives enormous amount of benefit to the DevOps world, because when they are doing the testing, they're creating the new environment which is totally isolated from other environment. It's very cost effective. They can spin up a new environment in many microseconds, because you eliminate the boot time of a virtual machine, you eliminate all those dependencies and the cost of RAM and the disk and all those things. You can have those created very quickly and swiftly. That is the core benefit. And not just that, the benefit goes to the production also, because then they can do definitely more consolidation. So let's get back to the main container, main topic. Hello and welcome. While doing my own Docker project, I made up a blog post on this technology, and it is very important for you to catch up with this technology, because this is the biggest change happening in the virtualization space in quite some time. For the last 20 years, we have been using what we call operating system virtualization. We achieve consolidation of virtual machines and systems on the same physical hardware. We are able to run multiple virtual machines using the technology. Basically, that started off with something called processor feature. It was virtual 8086 mode. I have a bit of a history on this technology, how this concept originated. In the blog post, you can go through to that. We will start off with the understanding that the assumption that you already have the understanding of guest operating system virtualization that we have been using. Docker is something on top of that. It's something new, and it improves upon that basically. Contrary to the operating system virtualization, it's a process virtualization technology. The benefit is obvious. Here you have only a single process which is virtualized. The kernel is shared between the host operating system and each of the container. So each of the instance or a virtual machine here is actually sharing the host kernel. So the storage of the kernel is not repeated. The boot time is no more there. And then definitely memory that is allocated by the kernel is not repeated anymore. Same goes for the disk. You have the single storage for the kernel. So this is more efficient. However, this magic is alone not achieved by the Docker engine. The base images, which are the core concept of the Docker engine, they also play a key role. you cannot create those base images. Those base images are created by the principal companies like Microsoft, like Red Hat, like Ubuntu. Those are providing you the base images basically. So that is how you achieve this goal. Otherwise, this process virtualization is not possible. But somehow with the Docker engine and those base images, it is not possible. Microsoft also caught up with this change, and now at this point in time they have all the elements available to get you up and running with the containers. And in this video we'll be doing creating the containers. We'll be doing a session on them to get you up and running quickly. So basically, as it is a process virtualization, the requirement is very less. The process doesn't take much memory basically for its own. You can start off with just 40 MB, which is just the minimum amount of memory that you can start a container with. So the disk requirement is also very less. I mean, the new version of Windows, which is customized to the container, which is called a Nano Server. There is also a Server Core Edition which you can use also. For example, Nano Server, it comes with an image size of only 100 MB, and when you install it, it occupies around 250 MB of disk space. That is a very small size, definitely. Now that is the Windows Server which is competing with Linux, because essentially you do not have any GUI into this server. You just have a command prompt. You don't even have a .NET installed in that. You have to add all those features into this server. So this is a server without all those features and a very stripped down version of it. So this is how Microsoft is joining this bandwagon. Microsoft have also very much streamlined the licensing model of this technology. I mean, on any version of Windows, either is standard or data center, you could have unlimited number of Docker containers. Yeah. There is also a Hyper-V isolated mode of it that additionally Microsoft offers, because as we said, it's a shared kernel thing. Now, in some instance, you might not have the base OS having the same update level or the same matching the version as in the base image of the Docker. So in that case, definitely you cannot share that kernel with the container. So you have to have this Hyper-V isolation where you have a dedicated version of kernel. That defeats the purpose of having the Docker in the first place. You would definitely be thinking about that. But in some scenarios it's useful, because now, for example, Microsoft have eventually released this Nano Server, which is similar to Linux server. So you might be willing to run this server alone in an isolated space. So that is one way of doing that. So you may call them pseudo Docker containers. There is some benefit of running to that, but if you ask me, the real benefit and the real concept comes from here, process isolation. That is the main thing you should be trying to run. And that definitely allows extreme amount of consolidation of number of processes. So you can run definitely more. But definitely there is one additional consideration when you run a shared kernel thing. As you can read, for example, if I go to Docker Hub, it is by the way, this Docker Hub is the place where all those images are present. So you get number of images coming from Microsoft, and you get number of images coming from other companies like Ubuntu, and all those Linux images are also there. But as you can see a note from here, that you might will encounter issues when you run a Windows Server container with the February 11, 2020 security update. So this means this definitely tells you the same thing, because it cannot have to be shared. So you will run definitely into new type of issues. For example, you patch the host OS, but you are not using the based Docker image which corresponds to that KB article. Maybe you have an older Docker image. So this new consideration definitely gives you new challenges. But definitely there are solutions also. For example, in case of Microsoft, you could use Hyper-V isolation, as I already mentioned. But definitely it does have a benefit of its own also. For example, now you do not have to really do all those patching. Microsoft will be releasing the new version of this Docker image, and you can redeploy your application on that. You just have to deploy, patch your host machine. So that is one good side of it. But downside is, so main takeaways from all of this is basically, there are a number of technologies for this process virtualization. Red Hat is coming with its own version, which is called OpenShift. By the way, IBM have acquired it, so they are working together with it. And there are a number of other competitors in the play. But Docker remains to be a prominent technology. Microsoft also adopted it. Number of Linux images, they are available on the Docker. And they definitely, this is leading the pack for now. All technology eventually land to the Docker, because if you use Kubernetes, often which is confused with the Docker or is considered as a replacement of Docker, actually it's only about the orchestrations of containers. And when you talk about container, mostly you're talking about Docker containers. Even in Microsoft, when you can create a container on Windows Server, as we have already seen, you have to install these things, Docker. So either it's a Linux Docker container or it's a Windows Docker container. This is the technology basically as of now. So which is commonly adopted. Microsoft also embraces technology and is using this technology to move along. So the key takeaway is, after you start up with this technology and learn it as becoming a de facto standard. And also you need, whenever in the Microsoft space, be careful of what you're doing. You could easily land up in doing Hyper-V isolation, which is something you do not want. But the core concept is process isolation. And the check is very simple. I already showed you. When you run the application, within the application, what will happen is you will have a process space will have the same process IDs as of the host. So the process should reflect on the host. If the kernel is not shared, this will not be the case. So this is your sanity check, for example. So as I said, in the DevOps, your CI and CD, sorry for the typo here, will be much more streamlined, because the cost of creating environment will be much more less. And the production, definitely, it's an enormous amount of benefit. Now, rapid provisioning, no boot time with a VM, consolidation at a much higher scale. On the same server, you can have now thousands of containers, because it is essentially a processor overhead now. No disk overhead, no shared kernel, no RAM overhead for the shared kernel, no memory overhead. There is downside also, as we said earlier, for the updates, but I think that definitely manageable in most of the scenarios. Portability to the solution is enormous because of the layered image approach. You just have to carry along with your source code, and you can run your application any corner of the world with the Docker container support is there. That is too much. And the Linux versus Windows debate also now is now fading away, because if, for example, you are using .NET Core, which you should be using, Microsoft is investing big time on this technology. Microsoft abandoned their mainstream .NET framework in favor of .NET Core, which is a cross-platform technology. So either on a Linux or on Windows, if your application is based on this thing, then it doesn't matter if your application is working on a Docker container or a Windows container. Windows also coming up with a stripped-down version of the system is hardly 100 MB of size. So you do not have all those GUI, the downsides, all those security talks are of the past now. Microsoft have really transformed itself to the market, and their acquisition of GitHub and now their acquisition of NPM also, most of the Linux-based things are really transforming into other standards. It's directly affecting the whole ecosystem, definitely. And last but not the least, this technology is relatively very simple to get along with, and this is very important to know. So you don't really have to be very much big Docker expert to use this technology. Even the most complicated part is to create this Docker file. Visual Studio and this technology create this file for you out of the box. You have to you can just copy them from there, like I did in this example. Yeah, it's good to know the parameters, but definitely you can take these things from there. So this is how you can use this technology, which is going to be a big game changer in the future, definitely. So this is the enough overview for you to get started. This blog post is now public, and also I have uploaded the source code for this sample, that the minor changes I had to do for like fetching this images of information within the container, and minor changing of selecting the right version of Docker file. So this I've made it, uploaded on my GitHub profile also. You can get it from there, and also all the relevant links how to get started on your version. Thank you for your time. Any feedback will be welcome.